It's a great privilege to join this distinguished gathering today to explore the French and American origins of sound recording. Today's symposium honors Edouard-Léon Scott de Martinville and his invention of sound recording on the bicentennial of his birth. We congregate in a big tent, a metaphor, perhaps, for our unity of purpose amidst our diversity. We sit directly above the vault that safeguards Edison's documentary legacy, and we strive to harmonize the American invention of sound recording with Scott de Martinville's. For this we draw on Scott's manuscripts, drawings, recordings, and other primary materials that we've identified in the venerable institutions that have safely preserved these documents for more than a century and a half: the Academy of Sciences, the Institute of France, the Patent Office, and the Society for the Advancement of National Industry. Among these documents are several dozen sound recordings made by Scott de Martinville between 1857 and 1860. We verified that they were in fact sound recordings by playing them back, something the French inventor never intended. This recording, from the archives of the French Academy of Sciences, was made a full 17 years before Thomas Edison invented the phonograph. As you might imagine, our playback was considered newsworthy, as it somewhat disturbed the narrative of Thomas Edison being the first inventor to record sound. At midnight on March 27, 2008, the New York Times website published Jody Rosen's article about our discovery and the sound we'd recovered. It was midday in Asia, Europe was just waking up, and within minutes the story was international news. Americans awoke the next morning to a revised historical reality in which the French beat Edison. The BBC located Laurent Scott de Martinville and asked how he felt about the resurrection of his great-grandfather's recordings.
I'm so happy for him because in his last will he asked his children and grandchildren to make sure that his discovery would not be ignored. This is a moral task that was given to us by his own handwritten will, which this one I have at home, and we were particularly proud in the family. We tried to restore his memory, my father and also my grandfather, and they had a marble plate that was put on the wall of the National Library, Rue Vivienne in Paris. That was the place where he lived for the last period of his life and where he passed away. And on this plate it is said that he had invented how to record sounds. As a matter of fact, when he passed away, he had just been, as a spectator, assisting to the presentation of Mr. Edison's invention in Paris. And his name was not even mentioned, and he was so upset that I believe that this is one of the reasons that eventually ended tragically.
This is going to require the rewriting of an awful lot of history books, isn't it?
Well, only a few sentences, but key ones.
What are those key sentences? That's the question we're here to answer today. What are the new facts? How do we interpret them? What's the new narrative, the corrected narrative, of how Scott made the invisible force of sound visible, of how he made the transient echo permanent? How do we square this achievement with Edison's invention of the phonograph 20 years later? How do we reframe the accomplishments of these two men who independently invented sound recording? At this symposium today are people for whom these questions matter. You are the ones who will write these key sentences. You're teaching the history of sound recording at universities. You're writing the next great biography of Edison, or the ultimate textbook on humanity's control over sound. You're studying the interplay between pure science and applied technology. You're writing master's theses, doctoral dissertations, historical articles. You're making documentaries. You're interpreting history for park visitors or telling the story to your readers, listeners, or viewers. The facts matter, and getting the story right matters. To this end, the park recently opened an exhibit that asks, who invented sound recording? And in answer to the question, affirms that sound recording was invented twice, the first time by Scott in the 1850s, and again in 1877 by Edison. Scott called his invention the phonautograph. Edison called his the phonograph. Each invention was a significant technological achievement in its day. The citizens of France and the U.S. rightly take pride in their inventors' accomplishments. But today, as we prepare to rewrite the history books, I hope that we can transcend the overt nationalism of past narratives which divide sharply along country of origin. French texts go like this. Scott invented the phonautograph, from which Edison obviously took the idea for the phonograph. American texts go like this. Scott invented the phonautograph, and why on earth he didn't think of playing back his recordings is beyond our ability to comprehend. Or, as Adam Sternberg wrote upon reading the Times piece, de Martinville's day of international glory has been delayed, sadly, by the fact that his phonautograph was designed to record sounds, but not to play them back, making it both the world's first and most useless recording device. Actually, the phonautograph was quite useful, indeed a genuine technological breakthrough. For years it was used in the nascent field of acoustics for measurement, experimentation, and teaching. As Patrick Feaster has written, seeing sound was no mere half measure. As a laboratory instrument, the phonautograph was no less complete in function than a seismograph that could record earthquakes, but not recreate them. Let's take a few minutes now to examine the most important things to know about the first invention of sound recording. Edouard-Léon Scott de Martinville invented sound recording when he conceived of a machine that would do for the ear what the camera did for the eye. He first imagined an apparatus to gather and fix airborne sounds, patterned after the human ear, while editing Professor Longet's treatise on physiology. That was in 1853 or 1854. He cites both years. Physiology and photography were two of Scott's inspirations. In the same way an eye or a camera fixes rays of light, Scott sought to focus waves of sound through a funnel or a horn. In the same way the ear channels sound to the tympanum, Scott sought to channel sounds to a diaphragm of rubber, paper, or gold beater's skin. Here the anatomical analogies have to end because Scott needed a medium onto which speech would write itself, just as light wrote itself onto a photographic plate. And here he had to go beyond the analogy of photography because, unlike a still camera, his instrument had to record over time, as did the sphygmograph, which recorded the pulse of the heart on a stratum that advanced with time. The phonautograph similarly inscribed its signals by removing a fine layer of soot from that stratum, leaving behind a white trace of its motion. Now you might ask, why did they use soot? Well, the thin layer of carbon offered minimal resistance to the rigid and super lightweight stylus. Low friction and low mass are essential to capturing minute details in the signal. Scott made his first proofs of concept around 1854. Here we see crude tracings powered by speech on the left, a guitar on the right. In 1857, when he filed his patent, he was still noodling with forms his instrument might take. I should note that the phonautograph never took a singular, definitive form in Scott's hands. He reconfigured it between experiments for the task at hand, kind of like the modular approach taken by audio component manufacturers a century later. In this form, from 1857, a plate of lamp-blacked glass traveled underneath an inscribing instrument, in this case a bird's feather or a boar's bristle, driven by the vibrations of a diaphragm mounted to the bottom of the horn. The instrument looked very much like Anton Stuhlwinder's replica on display here today. Speaking, singing, or blasting a horn into the instrument causes the stylus to trace squiggles in the soot for just a fraction of a second. Scott left us only 2 phonautograms made with an instrument like this, neither of which offers recordings we can play, or more specifically, recordings that we can interpret when they are played. Scott's methods were unfortunately still imperfect. Early in 1857, Scott's phonautograph caught the attention of the Society for the Advancement of National Industry. The Society gave Scott funds to register his initial patent and to conduct experiments with members of the Society at his side, members such as Jules Lissajous. A pioneer in the science of acoustics, Lissajous first demonstrated the figures that bear his name while working with Scott in 1857. When we began our quest for Scott's recordings, Lissajous' dossier on the phonautograph was thought to have been lost. Fortunately, it was located in the Society's archives in 2008 as a direct result of our work. It preserves a number of experiments made in 1857 and shows us how sound recording technology developed over that year. For instance, here's an experiment in which 2 signals were recorded at once. One was made by a tuning fork, writing directly to the paper. Another is the sound of a tuning fork of the same frequency, recorded through the phonautograp's horn. See where Scott or Lissajous made marks on the paper? They were counting the number of vibrations to ensure that they were the same in each recording. Here they match exactly. The phonautograph passed the test. It could accurately measure frequency of airborne sounds. As you might imagine, the short duration of the flat recording stratum was quite limiting. Duhamel's vibrograph, invented several years before, offered an obvious improvement. Its rotating drum would record up to 20 or 30 seconds. This is the only image we have of the next generation phonautograph. It was an important milestone because in the second half of 1857, all of the elements essential to the recording of sound were in place. Let's listen to 2 recordings made on that machine. The first recording was made in the fall of 1857. On the top, Lissajous wrote, "This attempt proves clearly that this apparatus is capable of studying timbre." On the bottom, Scott wrote, "Sound of a deep voice held in proximity to the membrane." It's important to remember as we listen, this was not a performance. It was simply an experiment to test how the instrument would perform. Let me play the recording for you as we first heard it. Most prominent in our initial playback is the wavering of pitch. Remember, this was recorded on a drum turned by hand, and hand cranking is quite irregular, fast in one direction, slow in the other. The blue line at the bottom of this graph tracks the change in pitch resulting from the irregular cranking. Modern software allows us to compensate for these irregularities and listen to an experiment made 160 years ago. What we hear is a voice changing in intensity and timbre as the recording progresses. Clearly, this recording is imperfect. It initially captures only the first harmonic of the voice. The fundamental appears only briefly at the end. However, being from October of 1857, this is the earliest interpretable recording of the human voice we've been able to play. As noted, it's obviously pretty distorted, and it was exactly this type of distortion that scientists like Lissajous feared. Late in 1857, he wrote an evaluation of the phonautograph for the Society's Committee of Economic Arts. His evaluation began positively, acknowledging the originality and utility of Scott's invention. The phonautograph made invisible sounds visible. It fixed the fleeting echo onto paper, making sound available for study as it had never been available before. Lissajous noted the machine's ability to accurately inscribe both pitch and timbre. He declared the phonautograph would prove to be of great service to science. However, Lissajous wrote, Mr. Scott seeks in these traces information of a higher order. He believes his apparatus can indicate articulation. We believe on this point he is completely in error. Lissajous based his concerns on distortions in the recording chain, the movements of the membrane, the motions of the stylus, each introducing mechanical distortions that disfigure the vibration, as Lissajous wrote, as a mirror of irregular surface disfigures the features it reflects. Lissajous' concerns were certainly justified. We see those distortions here, and we hear them in our playback of all Scott recordings. But Scott's recordings got better with time. In fact, we can hear in their playback the articulations and nuances and inflection that Scott truly believed were in the traces. Neither he nor Lissajous could read the articulations by eye, but today we can hear them when we read the recordings by ear. So here's the crux of the problem that would frustrate Scott for the rest of his days. Limitations in the technology, limitations in acoustical theory, and limitations in his ability to demonstrate to the scientific establishment that there was more information in his phonautographic traces than met the eye. Here's another recording, also from late 1857. It's a test of the phonautagraph's ability to capture the timbre of a cornet. We'll lay a spectrogram over it so you can see as well as hear the changes in pitch and timbre. We'll first play the recording as it comes to us from the paper. Like the earlier voice recordings, it suffers from unstable hand cranking. Now, as we did with the voice recording, let's correct these errors in the time domain. Let's pause here for a moment to make two observations. First, we can clearly hear the sonic signature of a cornet, so we know that in 1857, Scott was able to graph sounds with a good degree of accuracy. Remember, there was no way for Scott or his contemporaries to hear this. For 150 years, no one knew for sure if Scott had succeeded in recording sound. Now, we know he did, because we can play his recordings and recognize what we hear. The proof is in the hearing. A second observation. You might be wondering how we knew this was an ascending major scale in B-flat, with A equal to 435. We could talk all day about this, but the short answer is we have to make a lot of educated guesses. For instance, we know that Concert 435 had been established in France months before this recording was made, and that piston cornets are typically B-flat instruments. So these decisions are quite defensible. But a major ascending scale? Why not a minor scale, or a series of evenly spaced whole notes? The ear and forensic evidence support this interpretation as well as they support the major scale. Yet here we have a very different picture of the historical record. So the observation is this. The playback of a hand-cranked recording, whether it was made on a phonautograph in 1857 or on a tinfoil phonograph in 1877, will always be mediated by interpretive choices made by the restoration engineer. The best engineers consider a slew of forensic assessments as guidance, but without strict time registration at the moment of recording, we face a whole series of interpretive playback challenges in the time domain. The fact is, sound and time are inseparable. I noted earlier that Scott explicitly sought to photograph the word, But a snapshot of sound makes no sense. Sound is perceived over time, so it must be recorded over time. For the phonautograph to become a useful audio measurement tool, it needed to mark the passage of time. So we were not at all surprised to find time code burned into Scott's recordings from 1860. It blew our minds, but it wasn't a total surprise. Scott's time code, actually a pilot tone in today's parlance, was written by a tuning fork adjacent to the audio recording. The fork vibrated at a constant and known frequency. One could count its vibrations to determine the exact time elapsed at any point along the recording, no matter how unevenly the crank was turned. Today, in an exercise undreamed of by Scott and his contemporaries, we can play back time-coded phonautograms with extraordinary precision in the time domain, without the need to interpret them as we do uncoded, hand-cranked recordings. A final observation before we hear some of these. In 1860, the phonautograph was at the vanguard of instruments that recorded sensory phenomena in real time, over time. Like sphygmographic tracings and zoetropic pictures, phonautographic recordings were pioneering forms of time-based instrumentation. Edison's phonograph didn't require this precision, at least not initially. His invention succeeded because it awed listeners with playback. Wow and off-speed reproduction were noted, but they were forgiven because playback was blowing their 19th century minds. We hope our demonstrations later this afternoon will impart that sense of wonder and appreciation to this 21st century audience. Okay, so let's listen to a few of Scott's most technically adept recordings. All were made with a tuning fork track, which relieves us from guessing about speed. All were made on a machine similar to Jean-Paul Agnard's replica on display in the Origins of Sound Recording exhibit. All are held at the Academy of Sciences and the Library of the Institute of France, and all were made in 1860, the last year for which documents survive of Scott's experimentation. This phonotogram was made April 17, 1860, 8 days after the iconic Au clair de la lune we heard earlier. Again, remember that every recording was an experiment. Scott's intent in this recording was to demonstrate the acoustic effects of declamation, to show the inflections of intonation. The selection from Othello is a piece Scott used repeatedly in his testing. Scott made this next recording on the following day. His objective was to study the combination of the uvular R sound with vowels. The same day, Scott recorded this phrase from Phèdre. It reminds us of Scott's aspirations for his invention. His vision was as much aesthetic as it was scientific. In his writings, he aspired to preserve for future generations the performances of eminent actors, those grand artists who die without leaving behind them the faintest trace of their genius. It also reminds us that Scott was indeed a man of letters. Note how this line consists of monosyllabic words. That's the same reason Scott's father used it for stenographic experiments in the 1840s. Next is an experiment to trace a vocal scale from May of 1860. Scott wrote in his notes that the diaphragm he was using clearly recorded the harmonics of the principal vibration. Although the next recording is undated, it too is from the spring of 1860. These are the opening lines of Torquato Tasso's Aminta in Italian, intended as a study of the tonic accent, meaning pitch-based stress rather than volume-based stress. This recording serves as something of a Rosetta Stone. At the bottom, Scott notes, "I was wrong. It should be umane forme, not forme umane, as written above." Before we heard this, we didn't know what Scott was wrong about. Was he referring to the transposed words written on the page, or to the words spoken in the recording? Once we heard the recording, we knew he transposed both. Admitting it was his mistake, saying, "I was wrong," is tantamount to Scott identifying himself as the speaker. And as you've heard, the voice in this recording is the same as in all other recordings from 1860. The lesson here, of course, is that we must listen to these recordings if we hope to rewrite the history books correctly. Othello, Phaedra, Aminta, the materials Scott chose for his recitations reveal to us a man of letters in mid-19th century Paris. This is also true for the songs he chose. Here he sings a melody from Cherubini's Missa Solemnis. Finally, we arrive at Scott's last phonogram, or at least the last we've located so far. In this recording from late 1860, Scott sings a lively rendition of Song of the Bee. It's one of his most melodic, joyful, and playful recordings. Unlike most others we've heard today, it strikes me as more than just an experiment. Like the Cherubini, this may be among the very first recorded performances. So as we rewrite the history books, here are a few key sentences for your consideration. Edouard-Léon Scott de Martinville invented sound recording in France 20 years before Thomas Edison reinvented it in the United States. When Scott built his first successful phonograph in 1857, he became the first person to capture his voice for future generations to hear. The telephone was the first instrument to send voices over long distances, but the phonograph was the first instrument to send voices into the future. The recordings Scott sent to us are humanity's first recordings of its own voice. Since we first introduced them 9 years ago, Mon ami Pierrot has taken his place next to Mary's lamb as a universal icon of the invention of sound recording. Appreciation of Edouard-Léon Scott de Martinville and his accomplishments is spreading too. In 2011, the Library of Congress inducted Scott's recordings onto its National Recording Registry, a juried list of sound recordings judged to be culturally, historically, or aesthetically important and worthy of perpetual preservation. In 2015, UNESCO installed humanity's first recordings of its own voice onto its Memory of the World Register, an international initiative that helps safeguard documentary heritage against collective amnesia and the effects of time. We can debate who took the first photograph, who made the first phone call or who captured the first moving images, but there is no debate about who made the first sound recordings. It's rare to know something with such certainty. Thank you.